Adobe, the early composite. Did you know the Adobe used in California missions built in the 1700s is also a composite? A composite material is made of two or more parts that is better together than any one of the parts alone. Carbon fiber is a composite material. It's used in race cars and aircraft. The carbon in carbon fiber is strong, but it's brittle. The epoxy is not brittle, but it's not strong. Together, carbon fiber make for a very strong and light material. In this video, we're going to make mud and Adobe bricks. Adobe is just mud with straw. We're going to let these bricks cure, and then we'll put them through a series of tests. Who will win? While we're waiting for the bricks to dry, let's take a look at where Adobe is used worldwide. Adobe was used in the missions in California and by the Indians. Adobe is being used today on new houses. Adobe was used in the 1600s in England. They call it cob. It was also used in New Zealand. And dating back to 500 BC, it was used in Iran to build the citadel. This spanned 44 acres or 1.6 million square feet. After drying, these are the bricks. The mud cracked in the mold. The Adobe is just fine. Let's see how much weight they can hold. First up, mud at 5 pounds. Good job, mud. Okay, next, 8 pounds. Can it withstand 8 pounds? Good job, mud. Well done. Next up, 16 pounds. Here we go. Oh! And the mud crumbles. Please welcome our next contestant, Adobe. We'll start at 16 pounds. Can it survive? And our winner is Adobe. That straw is really making a difference. For our next test, we'll test each sample against a sharp force. What better way to test than with a golf club? Goggle up. The mud sample just exploded on spot, so it didn't travel very far. And now for Adobe. I'm thinking that the straw will hold the pieces together longer, and that the pieces will actually travel further. What do you think? Sure enough, the Adobe pieces are traveling much further, and this is because the straw is holding the fragments together. As we can see here, the Adobe fragments are much larger. Now we're going to test our samples against a blunt force. We're dropping the samples from a height of 3 feet. Let's see how they do. Oh, the mud just shattered. Let's see how the Adobe brick does. Whoa, it didn't even crack. It's completely intact. What? What? The Adobe didn't rip apart or even crack. Well, since we have this sample, let's drop it one more time and let's see what happens. Okay, it cracked. But it's still held together, and I think that's really good for 2 drops. Now let's look a little closer. Yes, the mud cracked, but the fibers held it together, and that's one of the great things about composites. In mud, there wasn't much surface to hold the sample together, but in Adobe, there's straw and there's a lot more surface to hold the sample intact. The straw also helped out with construction and made it much easier to form walls that would stay up. So we've seen that Adobe is making homes better, and that's because it's a composite material. And again, a composite material is a material made of 2 or more parts that works better together than any part alone. Thanks for watching and happy engineering!